Hi everyone. This pictures is about the shaking table, the famous shaking table worldwide. Okay, this one is defense, earthquake simulation vibration device in Japan. It's a large shaking table device. Okay, this is a people. Okay, this is a person. Okay, this is I think is a real building. Okay, the is a prototype. Is prototype. Is like a prototype. Okay, actually this is a person. Is a different buildings. This one is ordinary house, ordinary structure. Okay, this structure adopts the isolation. Okay, we use isolation to isolate the earthquake energy input to protect the main components of the structure. The large shaking table, the dimensions is uh, 20 meters plus 15 meters. Okay, is a large shaking table. Uh, to conduct a test is very expensive. Okay, it's very expensive. It's a prototype constructions phase. Okay, we use the shaking table. It means large device phase. Okay, we use, actually, however, from the research point, okay, by conducting the prototypes like structures and tasks, we can obtain more convincing results, more convincing performance, okay, of the structure. Some other shaking tables is UCSD in America. Okay, it's the largest outdoor shaking table. Okay, needs Chongqing. Okay, Fuzhou. Okay, it's Tongji University. It's ours shaking table. Actually, now we have four shaking tables. Every table have the identical performance and the parameters. Okay, each table have 4 meters plus 4 meters. Every table can support 30 tons specimen. Okay, this is about the hybrid simulation. Okay, this is dampers hybrid simulation. This is bracing, steel bracing hybrid simulation. This is actually is high speed railway bridge hybrid simulation. Uh, I will have a brief introduction of how to conduct a hybrid simulation. Okay, from this picture, we can see we have a structure. Okay, the structure we call it analytical structure. Okay, the structure can be numerically simulated in the computer. Okay, the dampers we adopt a physical damper. Okay, the damper is tested in the lab. Okay, uh, between the damper and the structure there is a connection. Okay, there is some connections. The damper will provide a force to the structure, and the structure provide a constraint on the damper. Okay, so actually there is a force translation between the two, the analytical substructure, uh, the and the experimental dampers. Okay, so in every time point, okay, there exists a balance between the two substructures, force balance and boundary. Okay, uh, so in every time step, we obtain from the load cell, we obtain the force, okay, provided by the damper. We apply the force on the analytical substructure, okay, we we can calculate the response of the structure. Okay, then we obtain the structure's response, and we input the controller to control the actuator to give the displacement of the damper. Okay, in every time step, we realize the force balance. Okay, and realize the boundary between the numerical substructure and the experimental dampers. Okay. The second hybrid test is similar. Okay, is similar. We adopt the steel brace as experimental uh, components, experimental structures, and the structure is simulated in the computer. Okay, the third test hybrid simulation, we adopt the piece as the experimental components in the hybrid simulation, and the bearing and the girders is simulated in the computer. Okay, we use the actuator to translate the force between the two substructures and to realize the boundaries response. Okay, by the actuator. So the new test technology is very useful, as you say. Okay, in the lab we can test the important components, and other linear or easier to simulate components is conducted can calculate it in the computer. Okay, so we can reduce experimental fate. Okay, then we can realize a large scaled specimen. Okay, just as we can say for the shaking table. Okay, for the shaking table, the models it's usually scaled model. Okay, scaled model will produce some unreasonable results. Okay, we should carefully design the scale of the model. Okay, to reflect the practical performance of structure. In the hybrid simulation, actually, we can design because we only test some parts of structure in the lab. Okay, so we can adopt a large scale